This is our first lesson in section 1.4. We've got a lot to talk about in this section, so this is probably going to encompass about 3 lectures. So first of all, in this section, what we're talking about is approximate linear relationships. And these approximate linear relationships are related to what we talked about in section 1.3, except this is more real-world examples. What we're going to be doing in this is going to be using our scattergrams just like we did before, but instead of seeing our points in a scattergram line up exactly in a straight line, we're going to have to use an approximate line. I'm going to say that the ordered pairs form a blurry line. Now, by a blurry line, I mean that you can still see a straight line type pattern, but it's not a perfect straight line. And as we do our scattergram, and then we're going to try to draw the straight line, we're going to come to as close as possible to as many points as we can. That doesn't mean that the straight line that we draw is going to contain all of our points or even any of our points. Sometimes the best linear approximation doesn't contain any of your original points at all. What we want to do, however, is we want to make the errors in estimation as small as possible. In fact, the goal is actually to make errors sum to 0. And later on in your math career, you may do something called a linear regression by means of least squares. And that is what I'm going to try to kind of just show you in a general overall sense with the example we're going to do a little bit later. So let's just talk about errors in estimation a little bit here. Errors in estimation, what I mean is that when we have a point from our original data and we draw our line, if the point that we're showing is above the line that we've drawn, then the model that we've made is going to underestimate the true value. And in that case, the error is going to be represented as a negative value. Now, I'll do an error assessment later on in our example so you can see what that means. And then the other side of that coin is if the point that was in our original data is below the line that represents our linear model, then the linear model is an overestimate, and therefore a positive number is going to be used to represent the error. Now, you might want to keep in mind this whole little section here because you might want to refer to it as we come back to the example a little bit later on. So I'm going to go ahead and scroll down to the next section here, and we're going to talk about some problems that can occur. Now, when we have a model, an approximate linear model, we have some things that are problems, and one of those is something that we call model breakdown. Model breakdown occurs because the real-world set of circumstances are only valid in a certain area, and we can't make predictions beyond that original area. So that's what happens with model breakdown. Now, if you remember our SUV depreciation model that we talked about in the last section, what happens when the model gets close to 0, or when we see that after about 5 or 6 years the model predicts that the vehicle's value will be 0. Well, that's not ever going to happen. Your vehicle is never going to be worth $0. And that's kind of an instance of model breakdown. So models don't always work out perfectly. So in your text it talks about a salmon example and the fact that salmon become extinct at a certain point in time according to the model. But that's not actually true. The salmon are never going to become extinct, at least with the circumstances right now. So those are examples and ideas of model breakdown. Now, the last thing that I want to talk about is extrapolation and interpolation. So extrapolating a data means that you're going to make estimates or predictions based upon the information beyond the range of values that you already have. This is where model breakdown has, and we have less and less faith the further away from the original values we get. Now, interpolating means that you have that you're finding values within those that you already know about. And we have a little bit more faith in these. That doesn't mean that error can't occur, but it certainly has a little bit more faith. Now, the next lecture is going to contain an example, and we're going to see how to make an approximate linear model based upon that example. So we'll discuss.